Module 1, Lesson 25, Triangle Congruence by Angle, Angle, Side. This time we're going to prove triangles congruent using two angles and a non-included side. So this one's a little different. The angle, angle, side theorem says that if two angles and a non-included side of one triangle are congruent to the corresponding two angles and non-included side of another triangle, then your triangles are congruent. Now in this one, just as with all the others, corresponding is the key word, but in this one it's a little more important. So look here, there's an angle and a second angle, and that's to be expected. And then we have a congruent side. Look where the side is on our first triangle here. It is next to the purple angle, opposite the green angle. Here is our side here, next to the purple angle, opposite the green angle. This is important because the non-included side can be in two different places. It could have been over here on side BC, but then, which would have been next to the green angle and opposite the purple angle, and we would have had to then have it on EF, again, next to the green angle and opposite the purple angle. So watch out for this. The proof of the angle, angle, side theorem is very simple. Given two angles and a corresponding non-included side, how do we prove that these triangles are congruent? Well, very simply, because if we have two angles that are congruent, then we can say that the third angle is going to be congruent as well using our third angles theorem. And now we simply have angle, side, angle, angle, side, angle. And angle, side, angle is one of our postulates and therefore accepted as fact. So very easy proof on this one. Let's look at an example. We have two triangles here. Are they congruent? Well, I see an angle, and I see a second angle, and a second angle. Looking good so far. And we have a non-included side. So are these two triangles congruent by angle, angle, side? They are not. These are not corresponding sides. One really easy way to do this is to work around your triangle. Angle, angle, side. And then on this one, we go angle, angle, side. We go green, purple to side on the first one, and purple, green to side on the second one. So they are not in the same order, and we know that order matters. Look at some proofs for this. Absolutely nothing new on this. We look for the same things as we did with our other three triangle congruence opportunities. It's just we are looking for two angles and a corresponding non-included side. So let's look at our triangle here. I see a given angle and a given angle, and a reflexive side. Can't stop that. Reflexive. We should probably label our angles as given. So we need something more. Well, check this out. We have parallel lines. And we know parallel lines mean get out your purple pencil, draw the two sides of your figure. Here is our transversal, and it can be helpful to sketch in. This is where everything's going to go. And we know that the first thing to look for is alternate interior angles. And we have two of those. There's one right here and one right here. And those are not included in our figure. So one right here and one right here. Those are alternate interior angles. And the pink ones are included in our figure, so we are going to mark the pink angles. And redrawing your parallel lines and transversal is extremely helpful on these because it can be a little bit difficult to see which angles are included there inside the figure. And now we look at this, and I do believe that I see angle, angle, side. We can go blue, pink, up to the side, blue, pink, down the side. We have angle, angle, side. So we defined, we now explore, and then we write a proof. We're given, let's see, that would be blue angle. We used parallel lines and alternate interior angles to get our second angle. Reflexive property of congruence gives us our side, and then our triangles are congruent. So again, nothing new in the approach, just simply choosing a different outcome, looking for a different outcome. Now, proofs using corresponding parts. So now this one we want to prove that two sides are congruent. So we know that we need to get our triangles congruent first so that we can use corresponding parts. So let's get started here. What do we see? Well, there's an angle and an angle. That's given. And we have those angles. They're also given. And that's all we have, except there's our reflexive property. Now, will that allow us to make congruent triangles? Yes, yes it will. Angle, angle, side. So we go blue, purple to side. Yes, we can. So again, we defined, and then you set up your explore, angle, angle, side. Go through. Let's see, KBC. There's an angle. K and A, there's our angle. Reflexive, property of congruence gave us our side. We were able to use angle, angle, side theorem to make our triangles congruent. And now, look at your congruence statement here. Are KB and AC in the same position? Absolutely. You can even look at it on your triangle. There's KB and AC. They go in the right order and in the right position. So we can say they are congruent because corresponding parts of congruent triangles are congruent. We could also use this to say that segment KC is congruent to, which way did I go? I went blue angle to not marked angle, so that would be AB. We could also use this to say, what do we have left? Oh, this angle here. So angle KCB would be congruent to angle. I went blue angle to non-marked angle down the green side. So blue angle is A to non-marked angle B, and the side C. All of these are by CPCTC. And we have one more here. We've seen this guy before. Let's see what we're trying to do this time. I see two sides. Those are given. We also have reflexive. I don't think we're looking for that. We're trying to use angle, angle, side on this. So those sides are given. I can mark angle B and C by the isosceles triangle theorem. And what else am I told? That AM is the perpendicular bisector. I believe we would be looking for perpendicular. So that would be definition of perpendicular, and that would lead us to right angles, which will lead us to congruent, because we know all right angles are congruent. So we could have angle, angle, side. We're given our first side, and that let us write the angle by the isosceles triangle theorem. We are given perpendicular, which led us to right angles, which led us to congruent angles. All right angles are congruent. Then we can write our congruence theorem. And now we need to look and see, is everybody in the right order to prove that these two angles are congruent. We're looking at these top angles here. We wanted to prove that those are congruent. We go B back to A over to M, and C back to A over to M. Yes, they're in the right order. We can look at that on our diagram as well. B, A, M, purple top down to the right angle, purple top down to the right angle, so CPCTC. We could use CPCTC to give us any of the other missing angles. So hopefully by this point you are effectively drawing and labeling everything on your diagram using color to possibly help you see it better. Write it all down and define. Use your triangle congruence theorem to set up your explore to organize your statements and reasons, and then writing the proof should go fairly easily. So I hope you enjoy angle, angle, side theorem.